Thanks all for joining. This is a Farm Advisory Service webinar about water issues in the Northeast region, but probably applicable more broadly. Thanks everybody for coming along. We're going to do quick introductions at the start, and then we're going to launch into a couple of great presentations. I'm Brady Stevens. I sit within SAC's Food and Enterprise team based in Edinburgh, but I work a lot on kind of natural capital and nature-based solutions in my role. And I'll pass to Fiona.
Hi, I'm Fiona Salter. I'm an SAC consulting in the environment team. I'm a senior environmental consultant. And thanks for having me today. Kerr.
Hi everyone, I'm Kerr Adams from the James Hutton Institute. I mainly focus on water-related research with a main focus on the impacts of water scarcity on the agricultural sector and wider society, both now and in the future. I'm interested in understanding the risk of water scarcity, but also potential adaptation options as well. But yeah, great to be here.
Perfect, thank you both. Just a quick kind of agenda and housekeeping note. We're going to have the two presentations. We'll run one into the other. If anybody has questions during the presentations, feel free to put them in the chat. I should have access to that. And then at the end, we can, or equally, feel free to just make a note of your question, because we will have time for some questions and answers at the end. At which point you can raise your hand and ask your question. Great. And without further ado, I'll give the floor to Kerr. Kerr, happy to share?
Yes, no problem at all. I'll make that a little bigger and just let me know if you can't see those or if they break up at any point.
So far, so good.
Great. Well, hello everyone. I've given a little bit of an introduction to myself there, but I wanted to start for anyone that didn't know a little bit of a background to the James Hutton Institute. So we are a scientific research organisation based in Scotland and do a lot of our research both in Scotland, but also globally. And we have offices in Aberdeen and Dundee. And our kind of focus is on looking at innovative solutions to challenges kind of posed by the climate crisis and the nature crisis, looking on the impacts it has on the sustainability and the resilience of crops, land, and natural resources. And we do this work to help support kind of thriving communities, both now and in the future. And one of those big challenges that we see is very much on the availability of clean water. So that's what my talk is going to focus on today. Maybe a little bit of more background about where I'm coming from the talk today. So I started with a background actually in agricultural economics, looking at the return on investment or the adoption of different irrigation practices. And that was in a region where they were experiencing groundwater scarcity in the US. And I've developed my research interests into kind of generally in Scotland understanding how water scarcity impacts the agricultural sector now and in the future. And as I mentioned, that interest in trying to better understand those risks and identify adaptation options to help sustain the sector. So what will I cover in the talk today? So the theme being water scarcity. I'll give a general overview of water use in the Northeast, and then again a bit of an overview on the historical climate trends and also future projections for the region as well, and relate those to the implications across different agricultural systems, which will hopefully feed in quite nicely to Fiona's talk on what can be done to address those kind of implications at the farm level as well. So usually end the talk on limitations and things to consider, but given that we're talking about climate, science, I thought it'd be best to be kind of upfront and highlight that a lot of what I'll present today are model projections and definitely not predictions. And also to highlight that within those projections, there's a lot of uncertainty and complexity within those, which I'll touch on a little bit as the talk progresses. And I'll try and be as transparent as I am with the projections that I'm using so that you can kind of put them within the context of your own situation as well. And building kind of on that, it'd be really nice if there's a chance in the chat or if you can unmute to kind of understand what your experiences have been with water scarcity and what your concerns are, and generally just how research can help support you in mitigating those risks and adapting to those as well. So as I start that first general overview of the northeast. So on the maps here, we have just generally for Scotland, land cover from the UK Centre for Ecology and Hydrology. This is actually from 2020, but you can see in the northeast, there's a real mix of improved grassland and arable lands, which leads to the dominant farm types, especially cereals, but also mixed crop and livestock. And that's from the agricultural census from 2021. Just wanted to set that context. It's important as we relate some of the climate impacts to those different kind of agricultural systems. Then in terms of water use in the northeast, I want to highlight here the kind of water use in terms of abstractions. So in the northeast, of course, in the purple here, a lot from distilleries or looking at Speyside, but you can see there is quite a bit of a cluster in this light blue for agricultural irrigation, so water being pretty significant for the area as well. And then just a breakdown of how water is used in the area as well. So in the orange, these are mainly the abstractions that are for irrigation, are mainly from surface waters. So again, setting the context of the climate to these different sources as well. So in terms of climate in the northeast, I'll start with rainfall. And the graph on screen is a comparison between a kind of baseline period of 1960s to 1989, and the comparison of 1990 to 2019 against that period. So interestingly, in the northeast, actually in January, here you can see in the northeast, those red shades that highlights that there's been a percentage decrease in precipitation for the region. In February, kind of general increase, but you can see in areas of March, May, June quite wet, bit of variability into July, drier in August, and much drier generally across the country in September as well, but also getting drier in December when we look at those two periods. So those aren't projections, those are how the trends have moved from the 1960s to maybe our more current period. So generally less rain in March, May, August and September, and quite interestingly, less rainfall for December and January, which is slightly different for some other regions in Scotland. And these most of the maps that I'll be able to show you are available on our website as well. If you want to delve a little bit deeper into those, I'd be happy to share the link with that as well. So that's for rainfall. Another important factor is evapotranspiration, because rainfall is what's coming in and being available as water, but evapotranspiration is what we're losing to the atmosphere and to crops and different land cover types as well. And here, red, seen an increase in evapotranspiration, so more water lost. And you can see generally across the UK, with interestingly the exception of June, more red periods here, meaning there's a general increase across most of the months. No special trend here for the northeast, maybe getting slightly darker in in May and into July as well. Again, in comparison from that 1960s to 1989 baseline to the current period. So now into the climate projections and into the future, and this is where it might get probably as technical as it does in the talk, but I wanted to be very transparent in terms of the projections that I'm using, because there is a lot of them. So on the left-hand side of the screen here, these are RCPs, or representative concentration pathways, which are used to create the UK climate projections. So representative concentration pathways assume changes in greenhouse gas emissions into the future. And those changes in those greenhouse gas emissions are associated with different global temperature changes here. So representative concentration pathway 2.6 lower compared to representative concentration pathway 8.5. And these changes in temperature are assumed for the global surface temperature changes, which are compared to pre-industrial times, which is on average between 1850 to 1900. So I've circled representative concentration pathway 8.5 as that is the emission scenario that I'll be using to present for the projections. Now, to make it a little bit more complicated, in those representative concentration pathways, there are 12 different scenarios within those as well, which differ on precipitation and temperature, for example. And the UK projections have been kind of downscaled to Scotland by colleagues from the James Hutton Institute, and they've calculated those changes in precipitation and temperature across those 12 different scenarios, as I mentioned, for Scotland. So I wouldn't be able to present all 12 of these and the implications of them. Or we would be here all night. So I wanted to highlight here that I've selected the 0.5 as the projection, which I'll present in the upcoming slides. And I'm selecting this one here because it has mean temperature change of around 2 degrees and a precipitation change of somewhere about 2.5% change in precipitation, just to give an idea of the potential risk into the future, but also not wanting to go too extreme as well, trying to find kind of happy medium to present today. And again, if you want to look at these different projections into the future, they are available on the Hutton website as well, and you can compare and contrast between those. So what does this number 5 projection mean? Again, this is up to the period to 2050 now that we're comparing with that baseline period. And now presenting for rainfall. And this graph now gives a kind of general change, a decrease, no change, or increase. So any increase in rainfall is highlighted in blue, decrease in red. Interestingly, you can see that for March, previously there had been a decrease, but this projection now actually in the northeast are looking at an increase in rainfall. And to March, a bit of variability across the northeast as well, as you can see there, and then increase in rainfall into May and into June, and even mainly into July as well. So only decrease in rainfall in areas around April, August and September, but you can see again into those autumn and winter months, there is a decrease in rainfall in this projection as well. And here's a bit of a kind of graphical look at that to help with the quantification. So in blue, that's the early baseline period, the kind of pink color here, 1990 to 2019, and then the green is that 2050 projection. Yeah, and you can see those trends, so the decrease in rainfall in April and into August and September as well. These bars here are error bars because these graphs here take the average across the northeast region. And of course, there is variability across the region as well, to add another layer of that complexity and the uncertainty. But these are kind of errors of how it might change slightly across the region as well. So then on to evapotranspiration, a bit simpler here, not so much variability, a kind of general increase across most months. There is periods here in February where there's not much change into the future compared to kind of current periods, except for in the northeast. So mainly across the board here, increase in evapotranspiration. So that's the water that's being lost, maybe some limited change into December there. And again, you can see that graphically here for 2050. You can see increasing compared to most of the periods. I've just presented this from March to September, same with the previous graph, as this is our kind of main crop growing periods as well. So what's driving? So in some months having more rainfall, but across the board greater evapotranspiration as well. So it's kind of continuing to see that trend of less available water, as if there is an increase in rainfall, is being offset by that loss to evapotranspiration as well. But it's interesting, particularly with the rainfall, to see the variation across months as well. And this is just for one of those example projections. So you can imagine the variability across the multiple too. So what's driving the increase in the evapotranspiration is mainly from increasing temperatures. So again, this is the comparison 2050 to that baseline period of the 1960s to 1989. And you can see across the board in Scotland, increases in maximum temperature, and the northeast is no different. So that's mainly what's driving the change in water availability, as you can see from this graph. So with a lot more water being lost from evapotranspiration, and to mention some of those trends into the early growing season, March, April, May, potentially being drier as well, there is some implications for the different agricultural systems that I mentioned beforehand. So I'll start with crops, arable crops and grassland, which are mainly rain-fed, where these deficits could lead to less water being available, particularly in key growth stages, which could have an impact on yields into the future. Saying into the future, this may have already been the case with the dry couple of years that we've had as well. So that'd be great to hear if you are experiencing some of these trends as well. And then highlighted that a lot of livestock to mixed crops as well. So those reduction in grass yields can have implications for that sort of system as well, in the form of reduced stocking rates potentially, and the impacts of extreme temperature on livestock as well, but also input costs going up for the need for kind of winter forage and stuff like that too. Then, so not just on agricultural systems, the natural system as well, these changes in climate can also have an impact on the available water in our rivers and streams as well. So I highlighted at the start, a lot of the irrigation abstractions come from surface water in the northeast. So I've put a couple of graphs or a comparison here of the number of significant droughts. So this is when flows are lower than at their lowest for 30 consecutive days, and I'll discuss some of the implications of that in the next slide. But you can see, so this is the current period. So you can see in the Don, the Devon, and the Spey. Sorry, my cursor may be a little bit too big to pick that out, but you can see in the current period, or historically, so this being the historic period from 2007 to 2018, you're seeing significant droughts there, maybe 1 in every 10 years, 1 in every 5 to 10 years, potentially, but applying those climate projections and the impact that they have on surface waters into the future, you can see that some of those are starting to change. I think that's the Don and the Ethan catchment there, potentially for 1 in every 2 to 5 years, or even 1 to every 1 to 2 years as well. So the number of significant droughts set to increase into the future. And those can have impacts on likes of irrigated crops as significant scarcity events. Those are what lead to the potential for the temporary suspension of irrigation abstraction. And I think, yeah, there was some issues with that, particularly last year in the northeast as well. And if you can't get the water available in these key growth stages, then there's that risk to crop yields. But again, for other systems such as kind of extensive livestock systems, then these low water flows are also, yeah, impacting on drinking water sources for livestock, which have health and hygiene implications as well. So I'll wrap up with a little summary and some resources. So in terms of the climate projections, looking at March, May, August, and September for thinking about the baseline and what's already happening. We're seeing those months are getting drier, and some of them projected to get drier as well. So you look at this continuing into the future. Interestingly, the winter months in the northeast, particularly getting drier, which could actually have implications for the amount of water that's available and sustaining throughout the year, and the kind of compounding effects of that as well. And these general drier conditions can impact crop and grassland growth, but it also filter down into our surface waters. So the frequency of those significant droughts projected to increase, and that can have a result implications for temporary suspensions for abstraction, impacts for crop yields, but also for livestock and their drinking sources as well. So based on what I've spoken about today, I want to highlight that there's a wealth of resources that are available if you want to look further into this. I highlighted the tool that we have available if you want to look across different projections across Scotland that we have at the James Hutton Institute. But I also wanted to highlight the Centre of Expertise for Waters. A lot of what I've spoke about today is in a report that we published back in 2024 that gives a lot more context to the implications to different agricultural systems as well. And there's also a recent report that Fiona led and I was a part of that Fiona will mention. I'll allow Fiona to mention that as well, but guidance for irrigators and general guidance for water scarcity as well. And on the subject, of course, the Farm Advisory Service, a great resource along with Farming and Water Scotland as well, which you may already know about, but also wanted to highlight resource from SEPA for looking at surface water flows and kind of general water scarcity. SEPA have a drought risk assessment tool, which gives a live update of water scarcity in the region as well, and kind of ongoing reports of water scarcity, which can be really helpful for helping with early warning if that's something that you're concerned about. And then finally, just thank you very much for your time. Thank you very much to Brady and the Farm Advisory Service for the opportunity to speak to you all today. And thanks to my colleagues who've done most of the work in the climate projections and things like that as well. Yeah, happy to take any questions. And if you want to share experiences or collaborate and don't have the opportunity to do so today, my email's there. And yeah, happy to chat anytime.
Thank you so much, Kerr. Really, really great overview, giving people a little more context about what's happened already and what we might be looking at in the coming years. I'm sure there will be questions. Please continue to pop those in the chat if you haven't had a chance yet, and we'll make sure to come to all those at the end. And now I'm gonna hand over to Fiona.
Perfect. Thank you very much. Yes, hi. Thank you for having me today. Yes, I said I was Fiona Salter. I help run the Farming and Water Scotland initiative with SEPA, and I help create knowledge transfer information on the Farm Advisory website. And as Kerr just alluded to, I helped produce a document that I'm going to be discussing today. So next slide, please. Thanks. So as Kerr alluded, water availability within Scotland has traditionally not been of main concern for the agriculture community. Scotland is renowned for its water. However, this might not be the case, and it was clear to SEPA that there was a lot of guidance on how to help build resilience against water scarcity for other countries, but it wasn't a Scottish specific guide. And we're quite a unique country. We have various different topographies, agricultural businesses, and we needed something to be tailored for our own country. So, and to increase our resilience, provide information about regulation, and discuss how it impacts the whole agricultural sector. So, with that in mind, the Centre for Expertise for Waters have produced, next slide please. Thank you. This guide. So it was a combination of SRUC, the James Hutton Institute, the University of Aberdeen and SAOS came together, and we tried to produce a usable document that farmers throughout the whole of Scotland could use to improve resilience to water scarcity. It discusses the current water situation in Scotland, how water is regulated in Scotland, the value, discussing how the value of your water to your business can be calculated, and then in the first section of the book, and then the second moves into how businesses can evaluate how resilient they are. And then we discuss ways that businesses can actually improve, doing different mitigation options, which I'm going to try and discuss today, to basically try and safeguard your business to changing climate. So, yeah. And then that's a link for the actual main document if anybody would like it. We'll put it in the show notes afterwards. But yeah, Brady, if you could move on to the next slide, please. Thank you very much. So the main question that agriculture or farmers and growers need to evaluate when it comes to resilience is, what is your risk to water scarcity? If there is no water on your farm like today, how long could your business cope? So within this guide, we've created like a step-by-step guide that you can assess your hazard, your exposure, and your vulnerability to create a risk for you that will help you form plans for moving forward to improve your business. So this can be as simple as, like, for your hazard, looking at using the SEPA water scarcity report from May to September. There's a weekly report that SEPA produced on their website, and it goes into all the different catchments. It's very simple to use, and it tells you from like normal to extreme, and it categorizes the whole country on your level of alert. And there, within the guide, we discuss all the different levels that you need to follow if you are in that. So if it's normal, business as usual, but be cautious. And then it moves into early warning, alert, moderate, significant, and extreme. And as you go through the different levels, there's different implications. And then as SEPA will keep you informed. However, as you move into the more significant and extreme, there may be limitations put on abstraction licenses. And then that is when mitigation options that you've put into your business can help you in times of water scarcity. There are a lot of things that you can do, which we'll come to, but trying to understand the risks to your business can help you plan for the future. And then we look at assessing your exposure, which helps you pinpoint where your weaknesses lie. Like, how many sources of water do you have on your farm? Do you rely on rain-fed or mains? Do you have storage on your farm? How can do you meter your peak demand? Can you pinpoint when exactly you will need that water in your farm, just to show when you might be more vulnerable? Will it, historically, if you've been recording your water scarcity risk, is that when that's going to be an issue? Like looking at Kerr's maps, the projections from before, is it likely that when you really need the water, is that potentially going to be when there is significantly less water available? And how can you build in resilience now to help in the future? And then looking at your vulnerability, have you thought about just general maintenance on your farm? Like, how do you combat day-to-day use of water on your farm to help build resilience? And then once you go through all those stages, you can create a drought risk profile. And then from that, there are stages and steps that you can follow to improve your management of water on farm. And then we also include a stage that you can do a dry run. Do a test run and see how that will impact your resilience on farm. We've also have a podcast on the Farming Water Scotland that discusses this in more detail, and you can get step-by-step instructions if you'd rather listen rather than read. So we've got the different options available to you. Next slide, please, Brady. But what does resilience look like in reality? So you can assess your hazard, vulnerability, exposure, and then your overall risk. But what can you do with that? Like, if you've discovered that your business is at risk, what's the next stage? It can seem like you have to climb a mountain, but there are short-term, medium, and longer-term options available to you that will have to suit your business. Like, if you see them all, it can get a bit overwhelming. However, if you break them down into what might actually suit your business, this is just a general farm. Obviously, this is not a specific farm. We're just trying to put everything that you potentially could do in one diagram to show all the options that may be available to you and your business. So it can be simple things from, like, as I said, maintenance, checking for leaks, doing a drought risk assessment plan, just so you can see where you potentially could make changes. One key thing that could help quite significantly is the use of technology. Like, there's always like technology advances that are coming through to help monitoring on farm, so you can get data relatively easily. And obviously technology comes from like low to expensive, but as technology is improving, like soil moisture probes and things like that are starting to become a lot more economically viable, and the information that you can get can come to your phone directly. And while you're in an office, you can be making decisions about your irrigation. Like, if this soil moisture probe is out there and telling you that your field is actually, it doesn't really need irrigated, you can potentially not irrigate that field when you normally would and save that water for when you actually need it, when the soil needs it. And then just making small changes like that can help you when water is scarce, and or abstraction licenses are having to be revoked just because you've made that choice. You might have, especially if you can store the water on your land, you can just build in that slight resilience, but it builds up over time. And then we can move into like more potentially longer term options, which is like building your organic soil organic matter, which I'll talk about in a few minutes. Involve further investment in technology. It could be like potentially moving into different irrigation equipment, which I will talk about in more detail. However, irrigation is expensive, it's an investment, and it potentially you might not be able to do it this year. So, but if you start to build it into future planning, it might become more viable as weather's changing and you can't guarantee in that water supply. Allowing yourself the ability to store water on your farm so that you have more than one source of water. If the rainfall is your main source, as the water availability potentially changes, your risk of not being able to have water when you need it also increases. However, if you potentially have offline storage, a storage lagoon, putting in rainwater harvesting on sheds, having rainwater tanks, building that within your business can allow you to store water when it's plentiful to use when it's not there. And just having that in the back of your head as a backup plan can massively help. Just help with like even like the fear of the water running out. You know that you have that. You can build in those extra days to buy you time when the water is scarce. And then we could also potentially move to a crop choice. Could you move to a different variety that is going to withstand drier conditions? Having potentially different crops, crops, different cover crops, making sure you don't have any bare soil. Just little things to help improve the soil health and different rooting depth to keep that structure and water retention within the soil. And then potentially moving to the longer term options. Obviously, peatland restoration is not going to fit every business. You would need to have peatlands or like a leaky dam, whether you've got the potential to put leaky dams in a barn or stream on your farm. That's not going to fit every business. However, it is a potential option that you could seek in the longer term advice on, and potentially working a catchment scale scheme that you're working with your neighbours and your local community. You can put different mitigation features in to slow the flow of the water, keep the water in the land for longer, and allow it to dissipate into the soil. So then the soil health will improve, water retention will improve, and then you'll have water within your soil for longer. And then we could move more into the nature-based solutions, riparian woodlands, woodland planting, meandering. But you could get a lot of the bigger catchment scale projects. However, those would be definitely working with other bodies and a wider network of people. However, if water scarcity is becoming more of a concern in your area and to your business, potentially looking for different ways to improve your resilience and water retention on farm might be to work with your local river body or your neighbour to just try and improve water management. However, those are longer term projects. You're not going to be able to do that in a few months. While if you did get a soil probe or like fix a leaking tap, that can make big difference now when water is scarce. And then I said I'm just going to break it down. So I'm going to focus the next two slides on irrigation and improving your soil organic matter. However, thank you. However, I'm happy to talk about any of the other features on this at the end, or you can email me about them. I appreciate I didn't talk about livestock, so like changing potentially your grazing pattern, mob grazing with crossing points and watering points away from the water. Just simple things like that can reduce the poaching, increase your soil health, and then just retain water where you need it as well. Yeah, thank you, Preeti. So, irrigation. Technically, Scotland, rainy, but this is changing, and irrigation, rain guns have traditionally been used because they are easy. Most people, if they need to irrigate, have the equipment. It's flexible with the topography. You can move them quite relatively easily. However, they are probably the least efficient way of putting water onto your land. And then potentially moving to a different irrigating system might be the way forward if you want to improve your efficiency. And it, depending on crop health, having the investment in the newer or a different technology may outweigh we'll always do what we always have had. Like drip irrigation is quite labor intensive at the start. You have to install it. It is getting better, but it used to be you'd have to do it annually. Some occasion, like they are getting more. The equipment's getting better. Like might last a few seasons, but it is the most efficient way of using water. So if you're finding that you do not have enough water for your crop, and changing to a different crop isn't an option for you, making the investment to move to drip irrigation, having that efficiency and the ability to schedule your irrigation when you need it, if you include it alongside like a soil moisture probe and weather station, the benefits might for your business be a win-win situation. However, it is very dependent on each business and where you are and whether you can afford to make that change. But with the way the climate might be changing, it might be a bit more beneficial to do this. The boom irrigation system is a lot more efficient than the rain gun. However, Scotland's topography and trees and pylons and things like that have issues with this system. It's not to say that it's not something that you could look into, but you just need to be aware that it needs the space to work. And then the sprinkler systems tend to be more the soft root type of irrigation system, just with the space that is needed. But there are definitely other options available to you, but investment would be needed. But I think that's why doing like the risk assessment to see how vulnerable and your hazards are, whether that would make your investment into newer technology might be a benefit to your business. And then next slide. And then improving organic matter. So improving your organic matter in your soil will dramatically improve water retention within your soil. And then therefore you will have that store of water within your soil. However, improving organic matter is something that takes time, but it doesn't mean that you shouldn't do it. It just means that the more that you start to improve the organic matter now, the benefits moving forward will be great. So like the reduction in erosion, the water retention, the keeping the nutrients where you want them, and the soil can withstand drier periods. So whether that's you keep the soil, like, I don't want to use the word regenerative, but I'm going to use regenerative agricultural techniques or traditional agricultural techniques, keeping the soil covered, mixed farming if you can, minimum soil disturbance, having the continual living roots between the buffer strips, maybe widening your buffer strips in fields that are more liable to erosion, and just having different potentially crops within, just to have that different rooting depth so that the soil has more protection and can start to improve and become healthier moving forward, and therefore become more resilient to a changing climate. It's not going to happen overnight, but something that will definitely help you with soil, water retention within your soil moving forward. And that is my whistle stop tour. So my next one is, thank you. Sorry, it was a whistle stop tour, but I didn't want to, it'd be quite nice to have some questions afterwards. But there is a lot of things that farmers can do to become more resilient to water scarcity. However, it is very linked to what is best for your business. So that's why creating your own assessment of your business through the 1 to 5 stages will highlight to you what's most important to you and your business. And then you can then start to discuss from all the different options that are available what you should focus on for yourself and your business and what you want to happen in the next few years, however many years. So, but yeah, thank you.
Perfect. Thank you so much, Fiona. It was really, really great. What an amazing double act the two of you are to have to lay out the situation and then to say what to do about it. Any questions from the room? Please feel free, as I said, to pop those in the chat, or if you raise your hand, I believe I have a button that will allow me to allow you to talk if you'd like to chip in. But I have a couple that were just submitted in advance here that I can start off with while people maybe have a think. For Kerr first, when you were talking about those significant days with significant drought demand, significant droughts, and how are those defined? And those, as you're saying, they trigger those abstraction limits. So how does that process, how would that look in practice, and sort of who is making those decisions, or where does that come from?
So it comes from SEPA's water scarcity plan. So that's available online for the full details, but each river gauging point will have what's known as a Q95 value, which is the historically, if you take the flows as a histogram or kind of set them out, the lowest flows, the Q95. So yeah, historically those are the lowest flows. If the river levels dip below those, and the 5-day average of that is below that for 30 consecutive days, then that would trigger a significant water scarcity event. And it relates to what Fiona gave details about, in terms of SEPA will give those early warnings into moderate, right up to significant and into the extreme. But once a gauging station or where the data for the river levels is below the 5-day average, has been below that thresholds that's been set for 30 consecutive days, then that's when you're at risk of the temporary suspensions.
Perfect. Thank you. Great questions just come in the chat from Tracy. Tracy, would you like to ask your question, or are you happy for me to read it out? Let me know. Not hearing Tracy, so I will just read it. Is there any guidance on how long water can be stored for in IBCs, for example, for livestock use? Thinking of Legionella risk in particular, maybe one for Fiona.
I don't know if there's guidance. I know that you'd have to treat it, but if I can get back to you afterwards, if that is okay.
Yeah, I remember reading a bit about it. Sorry. Sounds good. One for follow-up.
Yeah, if that is okay, Tracy. Yeah, because if you store water, you can, but there will be definitely rules. I just don't know them off the top of my head. Can I ask? So obviously, you know how June was so different? Was there any? Is it just the projections?
Yeah, I guess actually when I was comparing the historic, this was just for the general trend looked like it was right across the country. So yeah, quite interesting highlights just some of those surprising things. You get the variability across different months, but I'd have to look at it in a bit more detail on that. I guess the evapotranspiration mainly driven by temperature for the evaporation part, but the transpiration might be having an influence on that as well in terms of the processes for crops transpiring or different land covers transpiring, but I can't say with any certainty whether it's that specifically that's having the influence on it. But so yeah, maybe another one for further exploration. Yeah.
Oh, thank you. I was just so different, so I was just.
Yeah, exciting that we're pushing the boundaries of the research with our questions here. It's good stuff. Another one for Fiona. In terms of resources and where people might go to if they want to get started with some of what you laid out today, what kind of resources are out there? If you could just briefly, summarize again for people.
Yeah, well, I think the good place to start would be the guidance document. The Farm Advisory Service has a lot of information. Farming Water Scotland, as Kerr said, has a lot of information. But I also think speaking to your local Rivers Trust, your local farm advisor, or even your neighbours, talk to your local community and find out what they're doing and what they've got planned. But there's a wealth of resources and potentially funding out there that you might not be aware of. So reaching out to all these different people might bring some opportunities to you as well. So the burden isn't just on your business as well. Sharing the load as the weather changes as well.
Excellent. Yeah. Another one coming through in the chat here. Would planting
Yes.
herbal lays tick the boxes for a good soil structure improver?
I want to say yes. It's without knowing the details, but yes.
Yeah, a
The
lot
right
of
place.
in the right places, and sort of deep rooted varieties is what you hear about a
Yeah,
lot,
well, I
right?
think it's just a bit of case of having the different rooting depths. It just builds that resilience of when they can different rooting depths can go down deeper, and it just builds that structure. If especially if it's crops, well, that's word. At the start of the growing season, things like that, it just helps, and then also it's going to be there for longer, and can bring all the nutrients and everything. So yes.
Perfect. Just some cross posting a little bit here. There's a new article out, I think, in the Crops and Soils Bulletin that is recently out that I contributed to, looking that is specifically was a bit of a roundup of soil carbon from arable perspective and how to things to think about, a bit of a so that's a good article maybe to check out as well. Thanks for the great questions. One more for Kerr. Please do pop any final ones in the chat. Coming back to those climate projections, Kerr, that you had in the early slides, and kind of there was sort of the different RPCs, RCPs, and then within each of them, some of those different ones to choose from there. When might you choose a different one, and how would you like to sort of look at that potentially in future research?
Yeah, so I think it's difficult because you can take almost like a median of those as well and put them into almost one projection in that sense. But I think it's always advantageous to, if you're doing that, to show the variability within different bands. So that's one way definitely of doing it. Looking at the kind of uncertainties and the ranges across those different projections. I think trying to other colleagues have been working on tools that can show it at different different extents across regions. So if we are talking about the northeast, you can bring up a kind of interactive map of those, and you can see because there's variability not just across those projections, but across the region. There's a lot of how would I put it? There's a lot of variability with the projections, I guess, at that extent. So that's something that'll be coming soon, and allowing people to explore and almost overlay that with where their farm or their holding is, and they can start to really delve into it there. And then I guess where to take them moving forward would be to also other colleagues are integrating this with kind of crop modeling as well. So you can actually look at the impacts on different cropping systems and the impacts for different crops, whether that's on deficits for soil water availability and the need for future irrigation demand, for example, as well. So those are the sort of directions in which the research is going.
Do you know when that's going to be available?
Hopefully pretty soon, to be honest. This is so a lot of the work we do goes in the cycle of the strategic research programme, which is funded by the Scottish Government. Next year will be the last year of the current cycle, so a lot of these tools will be coming out of those kind of early beginnings of those tools, and then hopefully into the next programme, be able to start developing those a bit more.
Excellent. Yeah, I imagine like with those sort of projections, climate change affecting so many different sectors, it's just like you're looking at all those intersections of like, okay, crop modeling, there's a lot of things that need to be looked at once we have that sort of more detailed projection. Great. Well, thank you both again very much to our presenters as well as for our attendees. We'll keep the time and draw it to a close there. But thank you so much for joining. We're all sort of reachable via, so yeah, please do get in touch if there's anything else. But thank you so much, and yeah, have a great rest of your evening, everybody.
Thank you very much. Have a good one.